Solve systems of equations by substitution. I've got a picture of a pitcher here. One is the pitcher, and one would like to be the substitute. He would like to go in place of the pitcher and perform the exact same operations or duties, and that's similar to solving by substitution. So let's take a look at a couple of examples. In the first example, I have two equations. So I have a system, y equals 4x, and the second one says x plus y equals 5. The first equation is written in a very simple form. The y is isolated. So I'm going to let that be the sub. It is going to substitute into the second equation. So when I write the second equation, instead of writing the y, I'm going to write what y equals. The y equals 4x from the first equation. And then I'll copy the rest of the second equation down. X plus 4x equals 5. I'll combine my like terms. X and 4x is 5x. If I divide both sides by 5, x is 1. So I have found one of the answers. I like to write my ordered pair right away. I know that x is 1, so I'm going to put the answer 1 in the x's location. Now that I know what x is, I can go back to the first equation because y equals 4 times x, and I know x is 1, so y equals 4. And the final solution is 1, 4. 1, 4 will make 1 plus 4 equals 5, and if I place 1 for x, 4 times 1 equals 4. So it is the solution to both equations. Let's look at another example. This one's a little different because no variable is isolated yet. However, there is one variable that will be the easiest to isolate. Do you know what it is? It's the x variable. So I'm going to move the 2y to the other side, and then it will become x equals a negative 2y plus 13. Now that I've isolated it, I'm going to place that in the other equation. It's 3 times x, but I'm not going to write x. I'm going to write what I know x equals, negative 2y plus 13. And I'm going to finish copying the rest of the equation. I'm going to change this to add the opposite. Now I have an equation that only has one variable. I'll have to distribute the 3, and I'll have negative 6y plus 3 times 13, 39, plus negative 5y equals 6. I can put my two like terms together. Negative 6y and negative 5y is negative 11y plus 39 equals 6. Now I'll subtract 39 from both sides. And I get negative 11y equals a negative 39, and a positive 6 is a negative 33. If I divide both sides by negative 11, y is positive 3. So when I go to write my ordered pair answer, I'm going to put that y equals 3. That's going to go in the second position. Now that I know that y is 3, I can use this equation to find out what x is, because x is negative 2 times y. We know that y is 3, plus 13. That's a negative 6 plus 13, and a negative 6 and 13 is 7. So we know x is 7. And we can substitute those values in for x and y and prove that our answers are correct. The last example, although it seems fairly easy, can sometimes be confusing. Both of the y's are isolated, and sometimes students don't know exactly how to start on this. In the first one, y is 4x minus 1. I'm going to write that down. In the second one, y is 2x minus 5. And of course, since they both equal y, they are both equal to each other. So I have an equation with variables on both sides. I will change these subtractions to add the opposites. I will move the variables to the same side, so I'll subtract 2x from both sides, and I get 2x plus negative 1 equals 5. Let's add a 1 to both sides. 2x equals 6, so x is 3. I like to write my answer down, so I already know that x is 3. Now I can take that 3 and plug it into either one of those equations that I want. I'll plug it into the first one and see what y equals. It becomes 4 times 3, or 12, minus 1, so y is 11. And my answer is 311. I have solved the system of equations.